Hi guys, one more calculation and then we'll move on to metric units and SI units. Let's say you have a problem like this. You see that this is 92.34 times and then open parentheses 0.456 minus 0.421. You should know that you do whatever's in the parentheses first. So you do the math over here and you subtract 0.456 0.456 minus 0.421 and you get 0.035. So you do this first. This is 2 sig figs, all right? When we do the multiplication, this is 4 sig figs and this is 2 sig figs. Your final answer is going to have to be rounded to 2 sig figs. So you're going to take the 0.035, multiply it by 92.34. Your calculator answer is 3.2319. You're not allowed to report that. What are you allowed to report? Just 2 sig figs. This is lower than 5, so you just keep as is. So your answer is 3.2. Now, normally you would have some units here and you would have to pay attention to the units. But I just wanted to make sure that if you are given problems that have subtraction with multiplication, addition with division, division with multiplication, whatever, you do pay attention to the sig figs of each type and then get your final answer to the right number of sig figs. Obviously, anytime you have parentheses, you always start with that. Okay? All right. Let's first talk about some metric units that I really need you guys to know. And the prefixes that are associated with them. What you're going to be using a lot this semester is for length, you're going to use meters. For volume, you're going to use liters. And for mass, you're going to use grams. Okay? So these are your basic measurements. You're going to measure things in lab throughout the semester. Length, meters, volume, liters, mass, grams. Now, in the metric system, you just put a prefix in front of this base unit. These are called the base units. You put a prefix in front of the base unit to make the base unit bigger or smaller. And these are things you probably had in an intro chem class, so this should be familiar to you. The prefixes I want you to know are all in the book, but we're going to add a few more. Capital G is giga, that's 10 to the 9. Capital M is mega, 10 to the 6. K is kilo, 10 to the 3. So these three make this bigger. So if we're talking about a kilometer, that is a larger distance than just a meter. If we're talking about a megaliter, it's much bigger than just a liter, all right? You should know the exponent, what that means, okay? Don't sit and put a whole bunch of zeros. Don't go 1, 0, 0, 0, 0, 0, 0. Learn how to do an exponent. Use the exponents, okay? And then the ones that are going to make the base unit smaller are these guys. Lowercase d is a deciliter, or a decimeter. That's 10 to the minus 1. Lowercase c is a centi, and that's 10 to the minus 2. Okay? Lowercase m, big difference between uppercase m and lowercase m. Lowercase m is a milli, and that's 10 to the minus 3. This mu, Greek letter mu, is 10 to the minus 6. Lowercase n is nano, 10 to the minus 9. Lowercase p is pico, 10 to the minus 12. And then lowercase f is femto, 10 to the minus 15. Okay? And then one we also use for length is an angstrom. You'll especially see that in chapter 7, I think it is, when we talk about wavelengths, because sometimes they'll report wavelengths in angstroms. An angstrom is only associated with length is 10 to the minus 10. All right, so you need to be able to switch from one metric unit to another, and the only way you're going to be able to do that very, very easily is if you have these exponents memorized. So go ahead and get started, get some index cards, and write the prefix on one side and the mathematical meaning on the other side. So for example, you'll have an index card that'll say centi on one side, and then on the flip side it'll say 10 to the minus 2. And you should also know the abbreviation or the symbol. So make sure, like if I do this for you guys, you're not telling me, well, what is that, Dr. Wabi? That's a micro, okay? And you should instantly know that micro means 10 to the minus 6. Or if I do this, you should know that that's a pico, and that immediately, you know, is 10 to the minus 12. Okay, so know your prefixes, and we're going to use them to convert from one unit to another. All right, let me just go ahead and jump ahead and talk about converting one metric unit to another and using dimensional analysis. And then I'll come back and pick up on SI units, and we'll do, what else here? We'll do density, and we'll do temperature. So I'm jumping ahead on our what you need to know list, but that should be fine. All right, since we're doing metric conversions, let's go ahead and do some metric conversions. All right, you guys may have heard of dimensional analysis in intro chemistry classes. What is dimensional analysis? This is a technique where you are using a conversion factor to convert from one unit to another. All right. Right now, I'm just focusing on metric conversions, but then we'll also learn some English metric conversions and just conversions in general using dimensional analysis. So let's say I have 3.63 nanometers, and I want to convert it to meters. How do I do that? Well, we need a conversion factor that will relate nanometers to meters. All right, we already know that the word nano means 10 to the minus 9. So this is what we set up. With dimensional analysis, the units that we want to get rid of, we put down here. The units we're looking for, we put up here, okay? This is a little trick that works all the time, okay? You give a 1 to the prefix. So this has a prefix in it, so put a 1 with the nanometers, not with the meters. And then you put the meaning of the prefix with the base unit. The base unit is the meters. What does nano mean? 10 to the minus 9, so you're putting it this way. Nanometers cancel, and you end up with 3.63 times 10 to the minus 9 meters. Easy enough. Okay, what if I have a prefix and I want to go to another prefix? So let's say I've got, let me erase this. Let's say I've got 2.85 microliters, and I want to convert it to, let's say, deciliters. All right? Now, many of you can do this in your head, but let me just show you how to do it correctly using dimensional analysis, okay? And rather than get confused, or do I move the decimal this way or this way, try to use exponents. It will be foolproof once you learn the technique. All right, so we're going to write this down, 2.85 microliters. This is a prefix and this is a prefix. So in order to do dimensional analysis correctly, let's go from the prefix to the base unit and then to the next prefix. All right, so I'm going to go from microliters to liters first. If I want to cancel this, I put microliters down here and I put liters here. Remember what I just told you a little while ago. The 1 goes to the prefix. What does the prefix mean? What does micro mean? Well, because we're going to have this memorized, micro means 10 to the minus 6. So we give the 10 to the minus 6 to the liters. That way our microliters have been canceled. Okay, now I want to go from liters to deciliters. So I put another conversion factor here. What unit comes here? Liters. Why? Because that's what I want to cancel. And then I end up with deciliters up here because that's what I want to end up with. Okay, who gets the 1? The deciliters gets the 1. Why? Because that's the prefix. So I'm going to put the 1 here. What does deci mean? Deci means, because we've got this memorized, 10 to the minus 2, 10 to the minus 1. Okay, so we're going to put that down here. 10 to the minus 1. Liters canceled. Okay, see what we just did here? All right, now I do the math. Okay, anytime I have an exponent in the denominator, if I bring it up to the numerator, it changes the sign. So if this is a negative 1 down here, it's a positive 1 up here. So positive 1 and negative 6 is negative 5. So your final answer is going to be 2.85 times 10 to the negative 5 deciliters. Okay? And that's how you do a metric-metric conversion when you're going from a prefix to another prefix. Now let me show you the really quick technique, okay? Really quick technique. So we'll use the same one exactly. So 2.85, you want to go to microliters to deciliters, okay? What you do is you write down the meaning of microliters first. So you write down 10 to the minus 6. And then underneath it, you put the meaning of deciliters, 10 to the minus 1. And then what do? Bring this up to the top. It becomes a positive 1. So your final answer is 2.85 times 10 to the minus 5 deciliters. See how fast I just did it? Sort of hopefully paying attention here. Let's try another one, okay? Let's say I have 1.93 centimeters. And I want it to become, let's say, kilometers. Okay? So what do? Centi is 10 to the minus 2. Kilo is 10 to the positive 3, right? Okay, bring this to the top. It changes the sign. So instead of being positive 3, it becomes negative 3 up here. Negative 3 and negative 2, negative 5. So 1.93 times 10 to the negative 5 kilometers. That's the quickie way of doing it. It's the dimensional analysis. You set it up, you cancel the units, you see what you're doing. The quickie way is just set it up this way and boom, you got it. But just don't forget that anything in the denominator, when you bring it up to the numerator, you change the sign. All right, we'll do a whole bunch of other dimensional analysis problems in the next videos. Okay.